Yes, 12V-4 or 14V-4 non-metallic sheaths cable with two neutrals is available and can be used for running two arc fault circuit interrupter circuits. Whether using 12V-4 or 14V-4 non-metallic sheath cable with two neutrals is cost-effective depends on the specific circumstances of your project. Firstly, let's discuss the advantages. 1 is space savings. Using a single cable for two circuits saves space in conduit and junction boxes. 2. Reduced labor costs. Installing one cable is faster than installing two separate cables, potentially reducing labor costs. 3. Simplified wiring. Using a cable with two neutrals eliminates the need for separate neutral wires for each circuit, making the wiring process simpler. Now let's discuss the disadvantages. 1. Higher cost per foot. 12V-4 or 14V-4 non-metallic sheath cable with two neutrals can be more expensive per foot than traditional non-metallic sheath cable with one neutral. 2. Not compatible with all arc fault circuit interrupters. Some arc fault circuit interrupters are only designed to work with one neutral per circuit. 3. May not be code compliant. In some jurisdictions, using a single cable for two arc fault circuit interrupter circuits may not meet code requirement. Always check local building codes before using this method. Consider these factors. Firstly, circuit load. Determine the amperage and voltage requirements of each circuit to choose the appropriate cable size, either 12V-4 or 14V-4. Secondly, arc fault circuit interrupter compatibility. Ensure that the arc fault circuit interrupters you plan to use are compatible with the cable you choose. Thirdly, local code requirements. Check with your local building inspector to confirm if using a single cable for two arc fault circuit interrupter circuits is allowed. Overall, using 12V-4 or 14V-4 non-metallic sheath cable with two neutrals can be a cost-effective solution in certain situations, such as when space is limited or labor costs need to be reduced. However, it's essential to consider the factors discussed above to make an informed decision. Let's delve deeper into the specifics of using multi-wire branch circuits with shared neutrals, as this is essentially what we're creating when using 12V-4 or 14V-4 non-metallic sheath cable with two neutrals for two arc fault circuit interrupter circuits. A multi-wire branch circuit is a circuit that consists of two or more ungrounded conductors that have a voltage between them, and a grounded conductor, with the grounded conductor equally loaded by the ungrounded conductors. This configuration can save on materials and installation time, but it also requires careful planning and execution to ensure safety and code compliance. Here's a more detailed look at the considerations. First, the balance load is very important. The key to a properly functioning multi-wire branch circuit is balance loading. Ideally, the load on each ungrounded conductor should be approximately equal. This minimizes the current flowing through the neutral conductor. If the loads are significantly unbalanced, the neutral conductor can become overloaded, leading to overheating and potentially a fire hazard. The National Electrical Code, or NEC, requires that the neutral conductor be sized to carry the maximum possible unbalanced load. For example, if you have two 20-amp circuits sharing a neutral, the neutral conductor must be rated to carry at least 20 amps. Second, the common trip is very important. To prevent dangerous situations, the National Electrical Code requires that multi-wire branch circuits be protected by a device that will simultaneously disconnect all ungrounded conductors at the point where the branch circuit originates. This can be achieved by using a 2-pole or 3-pole circuit breaker. If one ungrounded conductor trips due to an overload or short circuit, all ungrounded conductors will be disconnected, preventing a voltage imbalance that could damage equipment or create a shock hazard. Third, there's the arc fault circuit interrupter compatibility. As mentioned earlier, not all arc fault circuit interrupters are compatible with multi-wire branch circuits. Some arc fault circuit interrupters are designed to monitor the current in both the ungrounded and grounded conductors of a single circuit. If these types of arc fault circuit interrupters are used on a multi-wire branch circuit, they may use as trip due to the shared neutral. Before using arc fault circuit interrupters on a multi-wire branch circuit, check the manufacturer's specifications to ensure compatibility. Some arc fault circuit interrupters are specifically designed for use with multi-wire branch circuits and will not nuisance trip. Fourth, conduit fill is also important. When running multiple conductors in a conduit, it's important to ensure that the conduit is not overfilled. The National Electrical Code specifies the maximum number of conductors allowed in a conduit of a particular size. Overfilling a conduit can make it difficult to pull the conductors, damage the insulation, and reduce the heat dissipation capacity of the conductors. Using a 12V-4 or 40V4 non-metallic sheath cable can help save space in conduit, but it's still important to verify that the conduit fill is within acceptable limits. Let's consider some potential cost-saving scenarios. First, material cost savings. In some cases, using a 12V-4 or 14V4 non-metallic sheath cable with two neutrals can save on material costs compared to running two separate cables. This is especially true if you are running the circuits over a long distance. The cost of the additional conductor in the 12V-4 or 40V4 non-metallic sheath cable may be less than the cost of the entire second cable. Second, labor cost savings. Installing one cable is generally faster than installing two separate cables. This can save on labor costs, especially if you are paying an electrician by the hour. The time savings can be significant if you are running multiple circuits. Third, space savings. As mentioned earlier, using a single cable can save space in conduit and junction boxes. This can be particularly important in situations where space is limited. For example, if you are running circuits in a crowded electrical panel, using a 12V-4 or 14V4 non-metallic sheath cable can help you avoid having to install a larger panel. Fourth, voltage drop reduction. In some cases, using a multi-wire branch circuit can reduce voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause lights to dim, motors to run poorly, and other electrical equipment to malfunction. By sharing a neutral conductor, the current in each ungrounded conductor is partially cancelled out, reducing the overall voltage drop in the circuit. However, there are also potential cost increases. First, the higher cable cost, as 12V-4 or 40V4 non-metallic sheath cable is generally more expensive per foot than standard non-metallic sheath cable with a single neutral. This increased cost can offset the savings from reduced labor and material costs, especially if you are only running a short distance. Second, arc fault circuit interrupter compatibility issues. If you need to use special arc fault circuit interrupters that are compatible with multi-wire branch circuits, these may be more expensive than standard arc fault circuit interrupters. This increased cost can further offset any potential savings. Third, the increased design and planning time. Multi-wire branch circuits require careful planning and design to ensure safety and code compliance. This can take more time than designing standard circuits. If you are not familiar with multi-wire branch circuits, you may need to consult with a qualified electrician, which can add to the overall cost of the project. Fourth, the potential for troubleshooting difficulties. If a problem occurs in a multi-wire branch circuit, it can be more difficult to troubleshoot than a standard circuit. This is because the shared neutral can make it harder to isolate the fault. If you are not experienced in troubleshooting multi-wire branch circuits, you may need to call an electrician, which can add to the cost of the repair. Let's talk about code compliance in New Jersey. The National Electrical Code, or NEC, provides the guidelines for safe electrical installations in the United States. However, each state and local jurisdiction can adopt and amend the NEC to fit their specific needs. In New Jersey, the New Jersey Administrative Code, specifically Title V, Chapter 23, adopts the National Electrical Code with some state-specific amendments. It's crucial to check with your local building inspector to determine the specific requirements in your area. While the National Electrical Code generally permits multi-wire branch circuits, local amendments may impose additional restrictions or requirements. For example, some jurisdictions may require that all multi-wire branch circuits be protected by arc fault circuit interrupters, even if the National Electrical Code does not require it. Others may have stricter rules about the types of arc fault circuit interrupters that can be used on multi-wire branch circuits. Always consult with your local building inspector before using 12V-4 or 14V-4 non-metallic sheath cable with two neutrals for arc fault circuit interrupter circuits to ensure that your installation meets all applicable code requirements. Here's a breakdown of the steps involved in determining whether using 12V-4 or 14V-4 non-metallic sheath cable with two neutrals is cost-effective for your project. First, determine the circuit requirements. Determine the amperage and voltage requirements of each circuit. This will help you choose the appropriate cable size, either 12V-4 or 14V-4. Also, determine the length of the cable run. This will help you estimate the material costs. Second, check the arc fault circuit interrupter compatibility. Check the manufacturer's specifications to ensure that the arc fault circuit interrupters you plan to use are compatible with the cable you choose. If you need to use special arc fault circuit interrupters that are designed for multi-wire branch circuits, factor in the additional cost. Third, check local code requirements. Contact your local building inspector to confirm whether using a single cable for two arc fault circuit interrupter circuits is allowed in your jurisdiction. Also, ask about any specific requirements or restrictions that may apply. Fourth, estimate the material costs. Get quotes from suppliers for both 12V-4 or 14V-4 non-metallic sheath cable with two neutrals and standard non-metallic sheath cable with a single neutral. Factor in the cost of any additional materials, such as junction boxes and conduit. Fifth, estimate the labor costs. Estimate the time it will take to install the circuits using both methods. Factor in the hourly rate of the electrician. Sixth, compare the costs. Compare the total material and labor costs for both methods. Also, consider any potential cost savings or increases due to arc fault circuit interrupter compatibility issues, code compliance requirements, and troubleshooting difficulties. Seventh, make a decision. Based on your analysis, decide whether using 12V-4 or 14V-4 non-metallic sheath cable with two neutrals is the most cost-effective solution for your project. If the cost savings are significant and you are comfortable with the technical aspects of multi-wire branch circuits, it may be a good option. However, if the cost savings are minimal or you are unsure about code compliance, it may be safer to use standard non-metallic sheath cable with a single neutral. Now let's discuss some additional safety considerations when working with multi-wire branch circuits. Firstly, proper identification is very important. Clearly identify all conductors in the multi-wire branch circuit. Use different color tape or wire markers to distinguish the ungrounded conductors. This will help prevent accidental contact with live conductors. Secondly, the turn-off power is very important. Always turn off the power to the circuit before working on it. Use a voltage tester to verify that the circuit is de-energized. Even if you have turned off the circuit breaker, there may still be voltage present in the circuit due to backfeeds or other issues. Thirdly, be careful when disconnecting the neutral is very important. When disconnecting the neutral conductor in a multi-wire branch circuit, be careful not to interrupt the neutral path while the circuit is energized. This can cause a voltage imbalance that could damage equipment or create a shock hazard. Always disconnect the ungrounded conductors first and then disconnect the neutral conductor. Fourthly, use a qualified electrician is very important. If you are not comfortable working with multi-wire branch circuits, it's best to hire a qualified electrician. A qualified electrician has the knowledge and experience to install and troubleshoot multi-wire branch circuits safely and correctly. Here's a summary of the key points to remember when considering using 12V-4 or 14V-4 non-metallic sheath cable with two neutrals for arc fault circuit interrupter circuits. First, multi-wire branch circuits can save on materials and installation time, but they require careful planning and execution. Second, ensure that the loads on each ungrounded conductor are balanced to prevent overloading the neutral conductor. Third, use a 2-pole or 3-pole circuit breaker to simultaneously disconnect all ungrounded conductors. Fourth, check the manufacturer's specifications to ensure that the arc fault circuit interrupters you plan to use are compatible with multi-wire branch circuits. Fifth, verify that the conduit filled is within acceptable limits. Sixth, compare the material and labor costs of using 12E-4 or 14E-4 non-metallic sheath cable with two neutrals to using standard non-metallic sheath cable with a single neutral. Seventh, check with your local building inspector to confirm whether using a single cable for two arc fault circuit interrupter circuits is allowed in your jurisdiction. 8. Clearly identify all conductors in the multi-wire branch circuit. 9th, always turn off the power to the circuit before working on it. 10th, be careful when disconnecting the neutral conductor. 11th, if you are not comfortable working with multi-wire branch circuits, hire a qualified electrician. By following these guidelines, you can safely and effectively use 12E-4 or 14E-4 non-metallic sheath cable with two neutrals for arc fault circuit interrupter circuits. Now let's explore some alternative wiring methods that you might consider if using 12E-4 or 14E-4 non-metallic sheath cable with two neutrals isn't suitable for your project. Firstly, running separate cables is the most straightforward alternative. You can simply run two separate non-metallic sheath cables, each with its own neutral conductor, for the two arc fault circuit interrupter circuits. This eliminates the complexities of multi-wire branch circuits and ensures compatibility with all arc fault circuit interrupters. However, it may require more conduit space and increase labor costs. Secondly, using home run to panel is another alternative. A home run is a dedicated circuit that runs directly from the electrical panel to the point of use, without any intermediate splices or connections. This can improve circuit performance and reduce the risk of voltage drop. You can run two separate home runs, one for each arc fault circuit interrupter circuit, using standard non-metallic sheath cable. Thirdly, using conduit with individual conductors is a more flexible alternative. You can install a conduit system and pull individual conductors through it for each circuit. This allows you to customize the wire size and type to meet the specific requirements of each circuit. It also provides better protection for the conductors compared to non-metallic sheath cable. However, it is generally more expensive and time-consuming to install. Fourthly, using armored cable, also known as AC cable or BX cable, is another option. Armored cable consists of insulated conductors wrapped in a flexible metal sheath. It provides good protection for the conductors and is suitable for both exposed and concealed locations. You can run two separate armored cables, one for each arc fault circuit interrupter circuit. Fifthly, using metal-clad cable, also known as MC cable, is similar to armored cable but has a smoother metal sheath. It is also suitable for both exposed and concealed locations and provides good protection for the conductors. You can run two separate metal-clad cables, one for each arc fault circuit interrupter circuit. When choosing an alternative wiring method, consider the following factors. 1. The cost of materials and labor. 2. The space available for running the cables or conduit. 3. The level of protection required for the conductors. 4. The local code requirements. 5. Your experience and comfort level with the different wiring methods. Now let's discuss some common misconceptions about multi-wire branch circuits. Misconception 1. Multi-wire branch circuits are inherently dangerous. While multi-wire branch circuits do require careful planning and execution, they are not inherently dangerous if installed correctly and in accordance with the National Electrical Code. The key is to ensure that the loads are balanced, the neutral conductor is properly sized, and the circuit is protected by a 2-pole or 3-pole circuit breaker. Misconception 2. Any arc fault circuit interrupter can be used on a multi-wire branch circuit. As mentioned earlier, not all arc fault circuit interrupters are compatible with multi-wire branch circuits. Some arc fault circuit interrupters may nuisance trip due to the shared neutral. Always check the manufacturer's specifications to ensure compatibility before using arc fault circuit interrupters on a multi-wire branch circuit. Misconception 3. The neutral conductor in a multi-wire branch circuit carries no current. While the neutral conductor in a balanced multi-wire branch circuit carries minimal current, it is still important to size it properly to handle any potential unbalanced load. The National Electrical Code requires that the neutral conductor be sized to carry the maximum possible unbalanced load. Misconception 4. multi-wire branch circuits are always cheaper than running separate circuits. While multi-wire branch circuits can save on materials and installation time in some cases, they may not always be the most cost-effective solution. The higher cost of 12-4 or 14-4 non-metallic sheath cable and compatible arc fault circuit interrupters can offset any potential savings. It's important to carefully analyze the costs and benefits before deciding whether to use a multi-wire branch circuit. By understanding these common misconceptions, you can make more informed decisions about whether to use multi-wire branch circuits in your electrical installation. Finally, remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you have any questions or concerns.